angles and degree measures. All right, first of all, an angle looks something like this. All right, so we had an angle. This is initial side. So this is our initial side. This is where it all starts at. So we have an initial side of an angle, but we also have a terminal side. So this would be my terminal side. Terminal being where it ends at. So we look at this angle right here. It starts here, ends there. So that makes the angle. Obviously that's an acute angle, and that angle is less than 90 degrees. All right, so that's one type of angle where we have an initial side right here, and we have a terminal side that's here. So if you notice in that acute angle, it went clockwise, so counterclockwise. So if I look at this angle, which is an obtuse angle, all right, so this is my terminal side right here. It's my terminal side. Again, that's my initial side. So if I look at it, it's actually going counterclockwise, in the opposite direction that the hands of the actual clock go. So if it ever goes counterclockwise, you're actually looking at a positive angle. Positive angle. So counterclockwise actually gives you a positive angle measurement, and that's what a positive angle looks like. It'll actually go counterclockwise. And this angle, the angle I just drew, is somewhere between 90 degrees and 180 degrees. All right, so starting here would be 0 degrees. So you go from 0 degrees, and then it goes up to 90 degrees, over to 180 degrees, add 90 again, this would be 270 degrees. If add 90 again, you wind up at 360 degrees. So basically in trigonometry, you're gonna find that 0 and 360 degrees actually are the exact same thing. You actually get the exact same values at 0 and 360 degrees in trigonometry. But yes, these are what the quadrants are. The first one is 90, the next one is 180, the next one is 270, and the next one's 360. So again, that's going counterclockwise. Those would be the angle measurements for any angle. So if I think about a larger angle, we have an initial side here and a terminal side down here. So if you keep in mind, that angle actually kind of bent backwards. I mean, if you visualize it, it would have started here at this initial side, went past 90, past 180, and it wound up being down there. And that angle is somewhere in between. If this is 180 degrees, and this is 270 degrees down here, that's somewhere in between, somewhere between 180 degrees and 270 degrees. So that angle is somewhere in between that range. So we do have angles that are larger than 180 degrees in trig. In lower classes, you pretty much stop at 180. But in trig, we go all the way around the circle. For example, if I started with my initial side here and it went all the way around from that initial side, all the way around and ended in this quadrant. All right, so now my terminal side is right here. All right, so that's a pretty big angle. When you think about it, that's when it's definitely not 0. It's bigger than 90. It's bigger than 180. It's bigger than 270. And so it's somewhere between 270 and 360. So that's where the angle range in between. It's somewhere between 270 and 360. Again, that's a positive angle. It's a positive angle because we started here and we went counterclockwise the entire time. So again, that's how you represent a positive angle. So a negative angle, in order to graph a negative angle, you actually have to go clockwise. So this direction would be clockwise. So if I actually graph a negative angle, this is my initial side still, but this is my terminal side now. And that graph is definitely going clockwise. So basically clockwise is a negative direction. So clockwise, again, is a negative direction. So the direction were to graph a negative 95 degree angle. Well, first of all, to go negative 95 degrees, we have initial side here, all right? So negative 90 degrees is along this line, negative 95 degrees, we're a little bit further. So this would be my terminal side. And again, in order to graph a negative angle, you have to keep in mind you have to go clockwise. You have to go clockwise to graph a negative angle. So that angle will represent negative 95 degrees. So it gave you new directions. That would say graph a 430 degree angle. Now, the graph of 430 degree angle, what you want to find is a coterminal to that angle. So basically what a coterminal is an angle that has exact same terminal side as the angle we're looking for. Because it's kind of weird to graph a 430 degree angle because it's more than 360. So to find a coterminal to an angle, to find a coterminal to any angle, is to add or subtract 360 from it. And many times you like. Ideally, you want to add or subtract 360 until you get an angle in between 0 and 360. So since 430 degrees is obviously greater than 360, I would take 430 and I would subtract 360 from it. And if you subtract 360 from 430, you wind up with 70 left. So basically, 430 degrees, 430 degrees is coterminal to 7 degrees. It's coterminal to 70 degrees. So basically what that means is if you graphed it, you really don't see the difference between 430 degrees and 70 degrees. So when I graph it, I know that I'm gonna have initial side right here, and I'm gonna go around the clock, counterclockwise, once, and that gives me my 360. Then go up about 7 degrees more. It's about right here. So this angle actually looks like this, all right? But you have to visualize that angle went around the clock more than once. I mean, so it started here, it went around, and all the way around 360, ended right about there. So this is what 430 degrees looks like. So again, it would look just like 70 degrees if you actually graphed it, because generally you don't see how many times it went around. You're just gonna see the initial side and terminal side. So that's what a 430 degrees looks like when we graph it, and that's the process for it. Finding a coterminal and then graphing it.